How's it going, guys? I want to go over a few problems on this compounding interest thing, on this compounding interest sheet, since I'm not there to help you guys out. So I just want to go over a few problems and kind of explain what these formulas mean and what interest really is. So compounding interest is where interest earned over a set period of time is added into the principal amount invested, and future interest is earned on both the original principal and accumulated interest. So what that means is if you go to a bank and you decide to put your money into the bank and they tell you they have an interest rate of, let's say, like 2%, and you earn it once per year, what that means is that at the end of the year, you're going to earn 2% on how much money you have in the account. So at the end of the year, you have $100 in the account, you earn 2% of that, which is $2. And since this interest is going to compound, that means the next year, if you have $102 in your account, you get 2% of that, whatever that is, and you add that on top of that. So you earn interest on the amount of money, on the interest money that you earned. So that's what it means that's what compound interest is. It's compounding on top of itself. You earn interest from the interest as well. So to figure out how much money you have in your account, that's what these formulas right here are going to tell you. These formulas will tell you how much money you'll have in your account based off your interest rate and how long you're putting it in there for, and how many times that interest is going to compound. Because different banks or different places, they will give you interest in different ways. Some places will give you interest just once a year, which is called annual. They'll give it to you once a year. Some places will give it to you maybe quarterly, which means they'll give it to you every 3 months or 4 times per year. Some places might even do it continuously, where you're going to be earning interest, like, not, I wouldn't even say every second, because it's more frequent than that. You're just always earning interest every single moment. So those are the 3 different types of interest. You either earn it like annually once a year, or you earn it a certain amount of times per year, or you earn it all the time, every single moment. Well, I say 3, but it's really just 2. And that's because compounding interest, the n times per year, that's just, when you put in n equals 1, what you get is your annual interest rate. So compounding n times per year, if n is 1, you get your annual account. So annual is still compounding n times a year. It's just that the amount of times per year that you're doing it is just once. And on the left, you have all these variables. I'll let you read this stuff on your own to figure it out. But what we're going to do is we're going to go ahead and solve some problems so this video doesn't get too long. So we're going to start with number 2. So find the value after 10 years of a savings account that starts with $600 and pays 5.75% of interest, compounded quarterly. So what I'm going to do is, first I'll figure out, well, what formula am I using? Well, I'm compounding quarterly, so I know I'm not continuous. So I'm going to be using the second one, compounding n times per year. So I'm using the A equals the principal times 1 plus R over N, all raised to the N times T. And then from there, I'm going to look at the statement and pick out all my variables. So I'm told that I want to find the value after 10 years. So that means my T, or the time in years, is 10. I start with $600. So my principal amount, which is your initial value, how much you originally put in, is $600. I'm paying 5.75% interest. That's my annual interest. So that's my R. So you put that in decimal form, it's 0.0575. And we're compounding quarterly. When you compound quarterly, that means you're compounding 4 times per year. So your N is 4. That's how many times you're compounding per year. And then from here, just plug in all these values. And in this case, I'm solving for A. So I'm told to find the value in the savings account after 10 years. This A is the current value of the account after T years, which is 10. So my A, that's going to equal my P, my principal, of 600 times 1 plus my R, which is 0.0575, all divided by my N, which is 4, raised to the N times T, or 4 times 10, which is 40. From here, you put it into your calculator. Those blue calculators should be able to do this. And what you do when you plug it all in is that you end up getting $1,061.92. So after 10 years, you're going to have $1,061.92 in your savings account, which is pretty good. You're earning $461 for doing absolutely nothing. All right, so let's go on to number 5. Number 5, continuously compound $500 at a rate of 2% for 20 years was the final amount. That's a really weirdly worded problem, but what we're being told is we're going to continuously compound $500 at a rate of 2% for 20 years was the final amount. The key word here is that we're continuously compounding. So that means I'm using this last one. I'm compounding continuously. So I'm using the formula A equals the principal times E, or my growth factor, time or raised to the R times T. And I want to figure out, well, what's my final amount? How much will I have in this account after 20 years? So my principal, or the initial amount I put in, that's 500. My interest rate is 2% or 0.02. And we're compounding this for 20 years. So I'm going to plug this all in, and I'm going to figure out my final amount, which is A. So in this case, I'm solving for A. So A is going to equal my principal amount, which is 500, multiplied by E raised to the R times T, or 20 times 0.02. And same thing, the only thing you can do here is plug into a calculator and solve it out. And we get that the amount of money, the final amount in the bank account after 20 years is $745 and 91 cents. So that's how much money you'll have in that bank account after 20 years. All right, and now for the last problem, we're going to number 10. So number 10 is kind of a big problem. We're going to kind of take it step by step. We're told Teresa invests $400 so that her money will earn 1% interest for the first 3 years, then 4% after that. If both interest rates are compounded quarterly, how much will her account be worth in 10 years? Then I'm told John invests $400 into a savings account that pays 3% annual interest for the same amount of time. And then I'm told, did he make out better or worse than his sister Teresa? So I'm trying to figure out who made more money, Teresa or John, and by how much, and what rate would John have had to find to make out the same as his sister. So we're gonna kind of do this step by step. So I'm gonna figure out how much money does Teresa have after 10 years. So Teresa's case is kind of complicated. So she's gonna be compounding her money for 10 years. But the first 3 years, she's earning only 1% interest, and the next 7 years, she's earning 4%. And both these interest rates are being compounded quarterly, or she's going to be earning money on them 4 times per year, or earning interest on them, is a better way to say it, 4 times per year. So in this case, I'm using the formula A equals P times 1 plus R over N raised to the Tn, because I'm be compounding N times per year, or 4 times per year. So that's the equation I'm going to use, but I'm going to have to do it twice. I'm going to do it for the first 3 years, and then whatever I get there, that money is going to be compounded at 4% for the next 7 years. So before I can figure out her total amount, I need to figure out, well, how much money does she have in her account after 3 years? So after 3 years, I know that her interest rate in the first 3 years is 1%, so R is 0.01. Is for 3 years, so T is 3, and it is compounded quarterly, so N is 4. And then her initial deposit is $400, her principal amount. So plug this in, and we get that the amount of money she'll have in her account after the first 3 years is 400 multiplied by 1 plus my R of 0.01 divided by 4. All raised to 4 times t, which is 12, or 4 times 3, which is 12. And when you do that, you end up getting that after 3 years, Teresa gets or has $412.17 in her bank account. But I don't want to know how much she has after 3 years. I want to know how much she has after 10. But I need to figure out this amount, because this is what's getting compounded or gaining interest on for the next 7 years. So for the next 7 years, her new principal is now $412.17. Her new rate is 4%, so 0.04. She's still compounding quarterly, And this time, we're going to be doing it for 7 years. So when you plug all this in, we get that our A, or the amount of money Teresa will have in her bank account after a total of 10 years, is for $12.17, her principal amount for the next 7 years, multiplied by 1 plus R, which is 0.04, divided by my N of 4, all raised to N times T, 7 times 4, which is 28. So you plug this into a calculator, and what you get is that after 10 years, Teresa has a total of $544.60. So we're done with Teresa. Now we're going to go on to John. I want to figure out, well, how much money does John have after 10 years? So I want to see who did better, John or Teresa. So for John, he invests $400, that's his principal, into a savings account that pays 3% annual interest for the same amount of time. So it's 3% annual interest, so that means he's earning interest just once per year. So that's pretty easy. That's just going to be the formula A equals the principal times 1 plus R raised to the, use the variable T or M? They use T, perfect. So P times 1 plus R raised to the T power. So my principal, that's 400. My R is the interest rate. I think that was 3%. Let me double check. It is. So 0.03. And the time, or the amount of years he's doing it for, is 10. So we get that the amount of money he'll have in his bank account, which is A, will equal the principal amount, which is 400, multiplied by 1 plus his rate, which is 0.03, raised to the 10th power. And when you solve this out, we see that John has $537.57 in his bank account after 10 years. So it looks like Teresa was a little more well off by, what, $7.03, but she still had the better deal. So what I want to do now is I want to go and I want to figure out what rate would John have had to find to make out the same as his sister. So I want to figure out, well, what is John's R, this R right here? What did it have to be so that he made the same amount as his sister Teresa? So let's go ahead and divide this up. So Teresa, she made $544.60. That's how much Teresa made. And I want to see, well, if John, who put in a initial deposit of 400, what does his rate have to be, his R, what does it have to be so that he earns the same amount as his sister did in the same amount of time? The only thing I'm doing now is I'm just solving for a new R. I want to know, what does John's rate have to be so that he, in that same time frame, he made the same amount as his sister. So I plugged everything in, so I know what my ending balance needs to be. I want John to have an ending balance of at least $544.60. And I know it's going to be 10 years, and I know his initial amount was 400. What I don't know is, what does the rate have to be to make all this true? And that's what we're going to solve for. So the first thing I'm going to do is divide both sides by 400, and we get 1.3615 equals 1 plus R, all raised to the 10th power. From here, we take the 10th root of both sides. The 10th root of 1.3615 is 1.03134. And the 10th root of 1 plus R to the 10th power, these just cancel out, and that's 1 plus R. Subtract 1 over, and we get that 0.03134 equals R. So that tells me that John's rate has to be 3.134%. That's what he needs to find so that he at the very least matches his sister's amount after 10 years. So that's how you do this problem, guys. Just go ahead and finish up the rest of the packet rest of the sheet on your own. Since you will have calculators on the test, there's a high chance that this stuff will be on the test itself. So make sure you know it. I am going to take this for an other grade, so have it done, and I'll be taking that on Monday. Other than that, have a great weekend, guys.